We would like to present how long it will take to get 30% of Thorium-229.
Thorium-229 is a radioactive chemical element used in actinoid series of the periodic table. Atomic number 90. It is a useful nuclear reactor fuel that is used as an alternative, such as uranium. Thorium was discovered in 1828 by Swedish chemist Jöns Jacob Perlezis. It's used in photoelectric cells for measuring ultraviolet light of wavelengths. Added to glass, thorium yields glass with a high refractive index, demands as a component of mantles for gas and kerosene lamps, and has been used in manufacture of tungsten filaments for light bulbs and vacuum tubes. Thorium-229, it is estimated to be 3 times more abundant than uranium in Earth's crust. The problem that we have is that we must find 30% of Thorium-229 its rate of decay. In order to find the radioactive decay, we must know its half-life. Half-life is the taken time for the reactivity of a specified isotope to fall to half of its original value.
In order to find out how much time it would take to get 30% of Thorium-229, you start off by dividing by both sides by A in order to cancel them out. And all you're left with is T being the 1/2 on the left, and E to the power of rate of decay times the half-life of thorium, which is 7340. Now, in order to get rid of E, all you have to do is multiply Ln by both sides. You then have to divide the half-life of Thorium-229 by both sides too, in order to get rid of it. Now this will just leave you with your K, or your rate of decay, which is what you're trying to find. You just divide Ln 1/2 over 7340. You put that in the calculator, your rate of decay would be negative 9.44 or negative 0.00094. Since when put in a calculator, you would get e to the power 5, which just means moving the decimal 5 times to the left. Okay, now that you have your rate of decay, you can use your rate of decay to find the time needed to get 30% of thorium. Now, when incorporating a percentage in a function, you have to move it 2 decimal places to the left in order to be able to get the proper measurements, which would be 0.3. Then you just multiply by both sides by Ln in order to get rid of the E and divide by your rate of decay. And this means it would take you 127 million years in order to get 30% of Thorium-229, more or less, but mostly more.